Today I'll solve one numerical problem based on the application of Bernoulli equation. Here I'll calculate pressure in a pipeline. Now here is the problem statement. A pipeline in above figure, so here 15 centimeter in diameter, so this is 15 centimeter of diameter and it is an elevation of 100 meter at section A. At section B it is an elevation 107 meter and has a diameter 30 centimeter. This is 30 centimeter diameter. When 50 liter per second of water is passed through this pipeline, the pressure at A is 35 kilopascal. So here that A section, A point, the pressure is 35 kilopascal. The energy loss in the pipe is 2 meter of water. Calculate the pressure at B if the flow is from A to B. Now first the given data. So here the diameter at section A, dA, so that is 15 centimeter, so that is 0.15 meter. Diameter at section B, dB, that is 30 centimeter, so that is 0.30 meter. Then pressure at A point, that is PA, that is 35 kilopascal. Flow rate Q, so that is given, that is 50 liter per second, so that is 0.05 meter cube per second. Energy loss HL, that is 2 meter of water. Elevation at A, so ZA is given, that is 100 meter. Elevation at B, ZB, that is given 107 meter. So direction of flow from A to B. So these data are given. Now first we know the continuity equation A1 V1 is equal to A2 V2 or AA VA plus is equal to AB VB. So AA is pi by 4 dA square. So if I plug dA square, so 0.15, so AA will be 0.0177 meter square. AB is pi by 4 dV square, dV is 0.3 meter, so pi by 4 0.3 whole square, that is 0.0707 meter square. Now VA is nothing but Q by AA, so 0.05 by 0.0177, that is 2.83 meter per second. And VB, that AA VA by AB, 0.0177 into 2.83 by 0.0707, that is 1.22 meter per second. So we know VA and VB. Now apply Bernoulli equation. So Bernoulli equation is PA plus half rho VA square plus rho G ZA is equal to PV plus half rho VB square plus rho G ZB plus HL. So now we have to plug everything. So PB minus PA. So that is nothing but half rho VA square minus VB square plus rho G ZA minus ZB. So actually this is the water, okay, energy loss of something water, so we have to multiply by rho into G. So ZA minus ZB minus rho G HL. So plug all this value. So 35 kilopascal into 10 to the power 3, half, that rho is 999 water density. Then VA 2.83 whole square minus 1.22 whole square, rho 999, G is 9.81, ZA minus ZA B is 100 minus 107, then minus rho again 999 into 9.81 and HL is given 2. So now if I simplify, so if I simplify, we will get something minus 50.0245 pascal. So that is minus 50.02 kilopascal gauge pressure. Means at point B, that pressure is in vacuum. Means in B is the vacuum pressure, because negative sign is there, means vacuum pressure actually created in that PV section. So that's it.